I might get back user ID 1's to-dos. So we obviously don't want to allow that. This is a naive implementation, kind of a first pass, but not something you're actually going to ship because, when I add the to-do get milk from the store, I want to make sure that it's safe and secure. And this is for to-do application. If you're dealing with any other kind of more sensitive application data, you're going to want to be even more careful. So let's take the next step. And in this case, we're going to actually have a opaque token that is going to be generated in the user API when the user successfully authenticates and after that data has been returned. So we're going to put that into the user object, and then the client is going to get the user object, right? Because it still wants the name and the roles, among other things, but it's going to extract out that token and pass it to the to API and say, give me the to-dos for this user. And this token is just kind of a random string of letters and numbers. It doesn't have to be anything special. You just want it to be long enough so that it's relatively secure. And then the to-dos are looked up. Well, actually, the to API needs to find some way to look up a user's to-dos. And so the way it's going to do that is actually going to call out to the user API and say, hey, I have this token. What user does this token represent? Now, you can't actually have the token be a key into the to-dos database, because then you run into the same issue where a malicious client might iterate token values and get someone's to-do. So you always want to go back to the user API you want the to API to go back to the user API and say, hey, is this token valid? And what user is this token for? The to API then gets back that user as JSON, and there's the user ID that it can use to go into the to-dos database. So opaque tokens are definitely a valid solution. There are some issues with that. Basically, you have to maintain this user token mapping. So you have to store that in a database table or something like that. You have to reap it periodically because it's probably not good forever. It can be very chatty, and it really does couple the user API to almost everything. So that means that anytime, again, let's look back at this past slide, if I add an email API, a reminder API, a friends and family API, right? I continue to build these APIs. They all are talking to the user API whenever they get one of those tokens. So that it can work. It can be problematic as well. So this is where JSON Web Tokens, or JWTs, ride to the rescue. So now, instead of creating this opaque token, you create and you sign a JSON Web Token in the user API. Then that JSON Web Token, just like the opaque token in the previous scenario, gets passed to the client. The client extracts it and presents that to the to-do API. So there are a couple things about this token. This token can contain arbitrary data that is JSON, but this token is signed. So that means that the to-do API can now look at the token contents and get what it needs out of that token without talking to the user API. And because the token is signed, it can do that without talking to the user API, without that coupling, that network coupling that was happening in the previous scenario. So tokens, as I mentioned, can be signed. You can sign them in a couple of different ways. We'll talk about which way you might pick in a little bit. And it really is a JSON object. So you really can put in roles and other metadata if you want. I will say, just a side note, that there's two kinds of JSON Web Tokens. There are signed JSON Web Tokens or encrypted JSON Web Tokens. So an encrypted JSON Web Token is, just like it sounds, one where the contents are encrypted and you need a key to decrypt them. A signed JSON Web Token is much more common, and that's the one I'm going to focus on because that's the one I'm most familiar with, and that's the one I've seen in the wild the most. Signed JSON Web Tokens, it's clear text, or it can be very easily decoded to clear text, but you can't tamper with it because it's signed. And so if you tamper with it, the signature changes. And so you can verify the integrity of the JSON Web Token. So encrypted JSON Web Tokens are good for secrets. Signed JSON Web Tokens are good where you want to be able to verify the integrity of the content, but you don't care if the actual contents are secret. All right, so any questions about those scenarios real quick before I move on to actually breaking apart a JSON Web Token? Great reminder, questions get you a chance to win that swag. All right, so here's a JSON Web Token in all its glory. And all signed JSON Web Tokens have three main components. The first is the header. And you can recognize a JSON Web Token in the wild because of this EYJ0. Those first couple of characters are almost always the same because this is a URL. No, it's a base64 encoded set of strings. So this is the base64 encoded header, and EYJ, I guess it's EY, that is what the curly brace is. So anyway, you have a header, which is going to contain some metadata, and we'll talk a little bit more about that in the next slide. Then you have the payload, which is in blue. So headers in green, payloads in blue, and then the signatures in tan. So the payload is where things get interesting. That's that JSON object that you can put whatever you want into. And then the signature is basically a representation of the using the algorithm you choose. It is a representation of like a hash of the contents of the header and the I believe I'm not sure whether it's of the header or the header and the payload or just the payload. I should look into that. Signature. Anyway, this is the header. So we have curly brace. Again, this is JSON object. So we have an algorithm, we have a type, you can have other metadata in here, but this is just things that are about the JSON Web Token, not the actual business value. This is going to be pretty common across different JSON Web Tokens that you're generating. And here's the payload. And this is where it really starts to get interesting, right? Because you know, I'm not sure exactly how you're going to use JSON Web Tokens, but I expect a lot of your usage will actually be in consuming JSON Web Token, consuming JSON Web Tokens, where you really want this payload, and you're really going to take this apart and look at it and pull off the pieces that are interesting to you. So the keys of this JSON object are called claims in the context of JSON Web Tokens. And there's two main kinds or categories of claims. There are standardized ones that are included in that IETF standard. And then there are non-standardized ones, which may have a semantic meaning that has been agreed upon by other people, but isn't standardized, or it may not. And it may just be your own, whatever, your own business logic or domain-specific nomenclature. So the first four here are actually standardized claims. And I'm going to kind of walk through each of them because they're important. So ISS is who created, what entity created this JSON Web Token. The EXP is the number of seconds since the Unix epoch, but after which this JSON Web Token is no longer valid. Because remember, if you remember back to my first slide, JWTs are stateless, which means that they are good. You never have to contact back to like a server to see whether they're valid. So the expiration time is really, really important here. The odd claim is the audience. So that is, who is this JSON Web Token for? In the scenario that we talked about a little bit ago, the ISS, the issuer claim would be the user API, because that's what generates JSON Web Token. And then the odd claim is the consumer of the JSON Web Token, so the to-do API. Finally, there's the subclaim, which is that one that starts with 191, 1901, and that is who is the subject. That is who is this jot about. And so in this case, it would be me, Dan Moore. And then names and roles are not standardized claims, or name and roles are not standardized claims. And I just put in roles to show that you can actually put in complex data structures. It doesn't all have to be strings or Booleans or numbers. Anything that you can represent in JSON, you can go ahead and put into your JSON Web Token. Signature, just a cryptographic signature. So at the end of the day, we now we have the user API, generate the JSON Web Token, send to the client sends it back to the to-do API, to-do API verifies the signature, does some other checking of things, and gets out the user ID, and now can do a select star against the to-dos database for that particular user ID, knowing that that JSON Web Token hasn't been tampered with. So I mentioned earlier that I'd be.
I just have a quick question about.
Of course.
Yeah, could you maybe elaborate a little bit? Excuse me, about the audience claim? Sure. That I just have. I guess I'm curious of like how that's oftentimes leveraged, because it seems like, you know, if you're thinking about a microservice architecture, that it's like, I guess it's kind of counterintuitive that this stateless object, you'd want to get a new one for each service you might talk to or something like that. Because I think you said that this would be consumed by the API, or sorry, the to-do API in this case.
Mm-hmm.
Does that make sense? Like,
yeah,
I mean, why are you encoding that if you had a more general token that you could just pass to any arbitrary service or something like that?
Sure. So, I mean, you could have, the audience doesn't have to be a single value, right? So it could be multi-valued. And so I guess the idea is it's really kind of more of a being overly cautious and defense in depth kind of idea of I'm going to create this token, and you might imagine that in this application there might be a parent and a child, and they might have different kinds of privileges, and you might want to enforce that both on the client and in the microservices architecture. And so you could do that with the audience, right? You would have an API that was like a special parental API, and that would look for an audience that would only be added to the JSON Web Token when a parent signed in. It wouldn't be there for a child. So, you know, lots of times people just ignore this, right? To be totally frank, but it does give you that flexibility of saying, hey, who is this token for? You could make your entire application, microservices application, one audience, or you could break things apart if you feel like you need that level of permissions and granularity. Does that help answer your question?
No, that totally does. So what I kind of got was like, it's not like there's a canonical use for it. It's kind of up to the implementers, and you could implement similar functionality with custom claims, but it's just something else you can leverage if you need to.
100%.
Okay,
Yep.
awesome. Yep. Thank you.
And I should be careful, just to reiterate, well, not to reiterate, to of these 4 standardized claims, the meaning of the claim is standardized, but the actual implementation, like the actual like representation of the claim, is definitely not, except for the EXP claim. That's a claim where it's going to be a long, or a number of seconds since the epoch, but I've seen issuers be GWTs, I've seen them be URLs. For OIDC, actually, you need them to be a URL. And the audience, I've seen those be kind of random strings or integers or GWTs or arrays of those values. So that is all kind of super implementation dependent. Great.
Yeah, thank you.
Sorry, did someone else say something? I had someone put something in the chat. Was that the same person who I don't know how to pronounce his name. I'm sorry. Joao, is that the person who asked the question too?
I asked the original question. My
Oh, I'm
name's
sorry, Mason.
Winston.
Great. Okay,
Yeah.
cool. Great. So let me see if I can answer the questions in the chat. The audience as a scope of the user can access regarding different services. Is that correct? Yes. Although kind of as we kind of teased apart there, you can use that for pretty much any purpose, but the standardized idea is this token is about somebody, issued by somebody, and for somebody. And the audience claim that is who it is for. Let me know if I didn't, or let me know if that helps. Great. All right. Great. So let's talk a little bit about bearer tokens. So here we're going to kind of, this next phase, we're going to like talk about JSON Web Token security. We're going to talk about some other things that might be of interest in a distributed system where JWTs would be useful. And we might try a little bit away from like the nuts and bolts of JSON Web Tokens to like how they're used. So they're often used as bearer tokens, as I mentioned. And, you know, when you think about a bearer token, you want to think about like a car key. You know, this unless you have a super smart car key, which I have not actually run into any of these, a car key knows nothing about who's holding it. And so if you give it to me, I'm going to drive it nice and I can get to access to your car. I can drive it nice and safely. You give it to somebody else, they might not do such a nice job, right? So you want to be very careful when you're using a JWT as a bearer token, and you want to be careful how you take care of it. Because if somebody, if a malicious client or a bad actor gets a hold of it, they can, for the lifetime of that JSON Web Token, use it to present themselves to services as you. So this is a bad person. They somehow got my JSON Web Token, so they can now look at all my to-do APIs. All my to-dos via the to-do API. Now, JSON Web Tokens have a built-in security mechanism, as opposed to something like an API key where it is going to expire at some point. But that could be cold comfort if they are able to not just read your to-dos, but look at your bank account. So what should you do about tokens when you're passing back that to-do API? When you're passing back that token to the client, what should you do? Well, you have a couple options. You can actually store it server side if you're willing to kind of have session management, right? Because that's an option. Store it in a session, and then the client never actually sees the token. The client just makes requests of the server that holds the token in the session, and then that server is what calls out to and presents the token to the other APIs. And this is known as the BFF pattern. If you have a different risk profile, you can absolutely push it down to a browser.
Yeah.
If people do that, we recommend it's an HTTP only secure browser. And the nice thing about that is that any JavaScript that's running in your browser, if it's an HTTP only secure cookie, it can't get access to that actual token and call off to some remote server and say, hey, I've just found a valid token. It can still monitor the data that any requests to the to API make and that come back because it's sitting there in memory as well. But at least it can't store off the token for other usage. And then if you're going to store it in a mobile application, use something like the keychain or secure storage. All right. So now we move into the JSON Web Token footgun section. So this is, where I say, just like Golang is a powerful tool, but you can definitely shoot yourself in the foot with it. You can do the same thing with JSON Web Tokens. So it's not a huge long standard, but it definitely was trying to solve multiple different use cases. So there are a lot of configuration choices or some configuration choices. So make sure you use a library. As I mentioned, that's one of the benefits of JSON Web Tokens is there's a library for Golang, there's a library for JavaScript, there's libraries for PHP. Use library, keep it up to date. And then the other thing you can do is verify your claims, especially as a consumer of a JSON Web Token. So let's go ahead and look at some code about what that actually would look like. Is there some extra care we should have for storing JSON Web Tokens in the backend or database? No. So, I would say not necessarily. I would just treat it like anything else. I don't think you need to, it's not long lived. So it's not like a secret that you might store in a secrets manager or something like that. Um, I'm trying to think of, yeah, if you're storing it in a session or something like that, it might be stored in a database. I mean, I guess you could encrypt them and decrypt them every time you're using them. I guess the real question is, what are the JSON Web Tokens the keys for, right? Like that's saying, should I be very careful about about the keys, right? And if it's a key to a beater, like a really crappy old car, maybe I'm not as careful as if it's the keys to my new Porsche. I don't have a Porsche, but so assess your risk profile and then think about what you're doing with the keys to that, with the keys that give access. Does that answer your question? Good question. Okay. All right. So this code is available. It's Apache licensed. There's a link in the presentation, so you can download this code and go run it if you want to play around with this. So here we're using a symmetric signing key. So we have this signing key, and then lines 13 through, I want to say 20-ish. Lines 13 through 37, right? So right to here, this we're pretending is the user API. So this is the thing that's generating the JSON Web Token. Normally, obviously, in a real world scenario, these would probably not be in the same Go program. They would probably not even be on the same server. But for this scenario, they're in the same program. So we create this token, we put in whatever claims we want. We can add another claim. And then we can add in our data structure, right? So this is just an array of, 2 values. And then we use the library to sign this, and we get back a token string. Then that gets passed around the network somehow. We don't really care how for the purposes of this demo. And then it gets passed to the to API, which is basically line 42 on. And here we are actually going to parse it, again, using our library on line 43. And we specify what signature method we are expecting, because that's important. And then it will also do some other checks for us. Most of the libraries I've looked at across different languages, including this one, do a good job at checking the signature, and then often they'll check the expiration time. So if the expiration time is before now, that means the token is expired and shouldn't be used. And lots of times they'll throw an exception or they'll return nil or whatnot. But there's business logic we need to do too. And that is what lines 58 through kind of 73 do. We're looking at the expected audience. We're looking at the expected issuer. In this case, we're not going to look at the subject, but you could look at the subject. You could look at other custom claims. And this is obviously something that's going to happen over and over again. So it's great to extract to a library or some bit of shared code. But you just have to make sure you do this. Otherwise, you might end up shooting yourself in the foot. And that's pretty much it. At the end, we just go ahead and print out the claims, but this obviously is where you would get the to-dos if you were really building a real application. So this is the JSON Web Token. And you can see that it later gets turned into this data structure. And I just want to show you one other thing real quick. There are lots of different JWT debuggers out there. If you just Google for JWT debugger, you'll see it. But this shows you that this signed JSON Web Token, I can plug that into any of these JWT debuggers, and I get back all of this information. So because it's signed, again, remember, that means the integrity is assured, but it means that the contents are not secret. So let's go ahead real quick and make this fail. So let's say that we're actually not expecting the audience to be FusionAuth.io. We expect it to be example.com. And then it goes kablooey, and I should stop processing at that point, right? Because now at this point, I don't actually know what's going on. I might want to, again, depending on my system, fire off a warning log, you know, add something to an audit log file. I certainly don't want to hand back the to-dos because something's awry. This JSON Web Token is a valid JSON Web Token. It's just not something that meets my expectations for my system. So as I mentioned, there's other here. There's an example with public-private key pairs, an example with the wrong key. Feel free to clone this. It's in GitHub. So, and again, as I mentioned, I'll send the link. All right. So I kind of stole my thunder here. But you can put whatever data you want into a JSON Web Token, but unless you know exactly where that's going to go, don't put any secrets in because the contents are simply base64 encoded and they can be decoded by any debugger out on the internet if someone gets a hold of that content. So that's why we at FusionAuth often use GWTs for our subject, our audience. We don't want to use integers because integers leak data. And if someone else finds that JSON Web Token and they see the audience is, 105 or the subject is, 1,000,005, then they have some understanding that that application might have at least 1 million users or has had at one point 1 million users or something like that. So if you use a GWT, you can totally ameliorate that particular data leakage. But you certainly don't want to put something like a social security number or anything that you want to keep secret in a signed JSON Web Token. That might be a valid case for a encrypted JSON Web Token, or more common is you just put in the key and then in your backend database, you have a way to like look other things up, right? You make other API calls all behind basically the firewall. So again, just want to emphasize when you have a signed JSON Web Token, anybody who gets a hold of it can read the contents of it. William asks, what does GWT stand for? Sorry, it's also called UUID, Globally Universal Unique Identifier or something like that. That is, where's one? This right here is one. And there's a couple of different formats for it. But it is just a way for you to create a identifier that doesn't depend on, say, like a sequence or something in a database. Yeah. All right. Goodbye, Grumpy Cat. We won't see you again. Another JWT footgun is the length of your Hmac key. That is one of the symmetric algorithms that are supported, and you want that length to be, you want that key length to be nice and random, nice and long. If it's short, you actually can it can be brute forced, And this is an open source project that can show you that this actually works. If you have an Hmac key of like 4, in length of 4, it can crack in about 20 or 30 seconds. I tried to do it with a nice long one, and I got bored and hit Control C before it had made any progress. But make sure that's nice and long and random and not shared with any other systems. This is one that comes up pretty often. People are like, what a boneheaded move. The JWT specification allows you to omit a signature, right? So I said before that you can sign a JSON Web Token, which verifies the integrity, or you can encrypt it, which keeps the content secret. You also can not sign it, which means that you're not verifying the integrity of it. That turns a JSON Web Token from something like this into something like this. So you still have your 3 clauses for this signed JSON Web Token. You have your header, you have your payload, and you don't have a signature. The header changes from something like this to something like this, alg none. And then what you end up being able to do is anybody who discovers this can create whatever payload they want, append this header, pass that in to your application, your API, and that API won't check the signature. It might check the audience, right? It might check the issuer, but you have no way of knowing if it was just specially handcrafted or if it actually came really from the issuer that you expected, right? That user API. So this is worse than unsanitized input, right? We always say never accept unsanitized user input and do anything with it. You always want to sanitize anything coming from the outside world. This is actually worse. This is unsanitized credentials, and really can let, if you run into this, anybody who discovers this, unless you have other powerful, security protections that are protecting your APIs, they're gonna really cause you a world of hurt. So the specification allows this, and the simple fix is just don't ever allow none. And that means don't ever use it when you're generating JSON Web Tokens. Don't ever accept it when you're consuming JSON Web Tokens. Just don't ever do that. Now, I used to be a consultant, and as anybody who is a consultant can tell you, the answer to any question is always it depends. And so I had to put in this. If you have some other way to verify your JSON Web Token is unchanged, right? You might have client certificates, mutual TLS, or you might be using JSON Web Token in a microservices system that is not on the internet, right? That is totally in a private network, doesn't have any access to the internet has no access to it. In that scenario, where you have some other way to verify the JWT is not been tampered with, and you have done some benchmarking to verify to learn that the signing is going to materially impact your system. If those 2 things are done, then I think you could have a case for using the none algorithm. My guess is anybody who's in that situation probably isn't coming to an intro to JSON Web Token talk, but it's possible that scenario could happen, which is why I believe it is in the specification. I have done some benchmarking of the signing, and it does have a negative effect on your performance, depending on the algorithm and whether you're signing or you're validating the signature. It's between 2 and, I don't know, 10 times. So it's a material impact, but I would question whether that was like the hottest. I would question whether that is a premature optimization unless you have done the profiling and you know that your JSON Web Token signature validation is causing you issues. So let's talk about asymmetric key pairs. In the scenario where we are using JSON Web Tokens, I mentioned that the to-do API never needs to talk to the user API, but the honest truth is that when you have a symmetric key pair, like in the sample code I showed you, you have one shared bit of data, right? That shared secret, which means that when you want to rotate that shared secret, when you want to change that shared secret, you need to get that to both the user API, which is generating the JSON Web Token, and to the to-do API and any other consumers. Because once you change that secret, anything signed with the anything basically, if you don't have access to that secret, you can't validate that the JSON Web Token was properly signed, again with a symmetric algorithm like Hmac. With a asymmetric algorithm, you actually don't have that barrier, because just like you can have public private keys with digital certificates or GPG or PGP, you can do the same thing with JSON Web Tokens. So no shared secret is really good because it helps you scale organizationally. You can have one team be responsible for the user API and one team be responsible for the to-do API. And they don't have to, when the user API team decides to modify its key because it's part of their security protocols, they don't have to notify the to-do API or coordinate with them in any way. And it's actually better than that, because you actually can scale across organizations too, right? You could have one team that's writing the user API or one org, and then another org that is actually consuming the JSON Web Tokens that are produced by that user API. And they don't have to have any common employer or anything like that. The other kind of major benefit of using asymmetric keys to sign your JSON Web Tokens is security. And what do I mean by that? If you have a shared secret, so you have the same value on the user API as the to-do API, then you need to protect both systems pretty well. Because if someone breaks into the to-do API, they can get that shared secret. It's on the file system or it's in memory or someplace. If they can get access to that shared secret, now they can sign JSON Web Tokens in a way that is indistinguishable from those that are signed by the user API. I just want to repeat that. If the to-do API loses control of the shared secret it uses to verify the JSON Web Tokens, if that secret gets out in the wild or an attacker finds it, then that attacker can craft JSON Web Tokens with whatever payload it wants that are indistinguishable from those that are signed by the user API. So you really need to make sure you protect both of these servers. With a asymmetric key, the private key stays in the user API and it publishes the public key, and the public key, anybody can see that public key. And so in that scenario, the to-do API just uses the public key to verify that the JWT was signed by the user API. So you don't have as big of a blast radius if you lose something like the shared secret. Key rotation is easier as well. Now, there's no such thing as a free lunch. The public-private keys are a little more complicated to set up and understand, and they're a little bit slower. So how does it kind of work, kind of nuts and bolts? Well, this is our familiar old diagram. So the user API creates, after the user signs in and verifies their credentials, or the user API verifies their credentials, the user API generates a JWT, signs it with the private key, passes that down to the client passes that JWT back up to the to-do API. Now, in order for the to-do API to validate this key, to verify, to check the signature to make sure it's correct, it needs the RSA public key. So there are a couple options. You could actually push the public key to the to-do API, right, as part of the deployment process. Not a huge win, but it might work, especially if you don't want there to be any network connectivity between the to-do API and the user API. But a better solution tends to be to go get the public keys from a well-known URL. And some identity providers publish this in a non-standard place. There's a standard called JWKS, which is basically just a list of public keys and the algorithms that they're correspond to. So the Jwt API can now call this well-known API, this well-known endpoint, get all the public keys, and then cache them or do it every time, and then use those public keys to verify that the key was signed by the corresponding private key. Sorry, that the JWT was signed by the corresponding private key. And this is what the JWKS endpoint looks like. I'm gonna dig in. Actually, yeah. So this is, you have the algorithm for the key. You have a key identifier. Again, it's not 42. It's some random string because we don't want to leak data about how many keys we might have. And then here's the actual public key as it's been encoded. If you have more than one key, you can actually, and you probably will, you can actually put the key identifier in the header metadata of the JSON Web Token, and then that key identifier can then be used to pull the right value from that list of public keys. Yeah, so Zhao asks, what is K8A for? Basically, that is saying, hey, this is the public key identifier for, or sorry, this is the public key. This is the public certificate, not certificate, sorry, the public key for this particular key. And here, I should change this to be some random string of digits. This JWT was signed by the corresponding private key. So let's the consumer of the JSON Web Token match up, right? So the consumer of the JSON Web Token says, okay, I got this JSON Web Token. It comes in with key ID 42. I need to go find key ID 42 from someplace. Again, I could have it stored locally. I might go out to a URL and just grab all the keys that user API provides, and then I'll iterate them and look for the key identifier. And if there's one that matches, that's the public key that I should use to validate that this JWT was signed by the corresponding private key. Does that make sense? Cool, great. So let's talk about refresh tokens. I've kind of hinted around this, but the honest truth is that your JWTs should be short-lived. So because they're stateless, because anybody who gets them can use them as a bearer token, depending on how you configure your system, you want them to expire quickly because that lowers the risk profile. Refresh tokens tend to be longer lived, and refresh tokens can be used to basically mint new JWTs. Refresh tokens are this compromise because if you have a system without refresh tokens and you have your JSON Web Token live for a short period of time, like 5 minutes or 10 minutes, then every time that token expires, you need to actually send the user back to the user API and they need to relog in, which obviously is a total pain in the butt. Not so much fun for your users. Your users are probably going to go find another to-do application and you'll lose your VC funding and, maybe go work in a circus or something. I don't know. If you have a long-lived JSON Web Token, right, you say, hey, I'm not going to go live in the circus. I'm not going to go run off of the circus. I'm going to stay in my software development job. I'm going to set my JWTs to be really long-lived, to be days or weeks or months. Well, then anybody who gets that JWT now has access to all your to-dos for that long period of time. So refresh tokens solve that problem. So how do they solve that problem? Well, let's look at how this scenario might play out. So we have a user API. We now are generating not just a JSON Web Token, but a refresh token. We send those down to the client. Client stores them both off safely. And then the client presents the JSON Web Token to the Jwt API. So this is nothing different than what we've seen many times before. Let's say our JSON Web Token is good for 10 minutes. So 10 minutes go by, the client, the human behind this client, because it's always worth remembering that there's a human back there. The human's adding to-dos, they're checking them off, they're deleting some, they're assigning some to other people, they're having a grand old time. 10 minutes and 1 second goes by. The next time after that period of time, when the client presents that JSON Web Token, the Jwt API says, whoa, hey, hold your horses, cowboy. This token is expired. You can't get access to this functionality anymore. Now, the client can catch that exception, can look at it and say, oh, this is, I got an access denied from the to-do API, but I have this refresh token. So I'm going to go ahead and try to use this refresh token to get a new JSON Web Token. So it presents that refresh token not to the to-do API, but back to the user API. Now, the user API knows a lot more about the user than the to-do API. It knows if the user's logged out, if the user's paid their bills, if the user has been locked out by an admin, or if the user's session is still ongoing and just perfectly fine, right? That's the thing the user API knows about. So it can take that refresh token and it can say, oh, yep, Dan's good. I'm going to create a new JSON Web Token and I'll pass that back down to the client. The client can then present that to the to-do API and it's good for another 10 minutes. And so you can actually have that happen repeatedly. And the user is gaining prolonged access to their to-dos without the security risk of a long-lived JSON Web Token. Any questions about the refresh token flow? Great. All right. Oh, wait. Chris says, is there a practical difference between using a refresh token versus having logic that has the user call an API to refresh? Call and well, if I'm not sure what you mean by logic that has the user call an API to refresh.
Sorry, I'll just ask it verbally.
Sure.
So with the refresh token, it's just like some string that you're going to send to the user API to like refresh the token. Is there a practical difference between that and then the client seeing that the token's about to expire, the original JWT that they have is going to expire, and then calling an endpoint on the user API to get a new JWT?
Is there a meaningful difference between those two? Well, for one, you don't have to examine the JWT, right? That JWT can be totally opaque to the client, and you don't have to put any logic in there. I mean, I guess you have to put the retry logic and the catching the exception logic, but you don't have to examine the inside of the JWT. No, not really. I think the refresh tokens are part of the standard, the OAuth 2 standard, I want to say. It's its own kind of grant. So I guess there is a benefit there in that you can probably leverage more libraries and be more familiar to other developers who've worked with OAuth. But I don't see any issues with your solution. I guess the question is, the client needs to make sure that it passes the JSON Web Token, presents that to that API endpoint when the token is still valid, or I guess there could be some kind of slippage or grace period, but you certainly wouldn't want to accept like really old tokens, right? Because you don't really want to know, you don't really want to have anybody who finds a token lying around be able to go ahead and get a new token for that user.
Okay, cool. Thanks.
Yeah, you bet. Good question. All right, let's talk about deleting users. If in a distributed system, and also not just users, but user data. If you're in a traditional monolithic application and someone says, hey, someone sends you a GDPR request or wants to delete their account, you can definitely do on delete cascade, and any place that has data hanging off of that user ID will remove the corresponding rows, right? So very easy to remove all of the to-dos or any other private data. In a distributed system, there's no on-delete cascade. And so you have a couple options, but the one that we recommend is to use webhooks. And so you can basically have the client fire off one request to say, hey, delete this user. And then any APIs or services that are interested in finding out about user deletions can sign themselves up to get notified when a user is deleted. Then at that point, the to API can get the event, say, oh, Dan's deleting himself. I'm going to go ahead and delete all his to-dos as well. And you can actually, I don't know how common this is. This is something FusionAuth does. Maybe it's very common. I haven't seen it with other providers, but you can actually have this be transactional so that all of the APIs have to return like a thumbs up, I deleted my user data before this user API responds back to the client saying, hey, your deletion is complete, which can be a nice way to make sure that everyone's on the same page around the user data. As far as logouts with JSON Web Tokens, and in a kind of distributed system like this, you're really limited to deleting the refresh token. So how logout happens is the client accepts the logout request. They send a request up to the user API. They say, hey, this user wants to log out. That that API then invalidates the refresh token. So that refresh token can no longer be used to mint new JSON Web Tokens, sends a response, and then the client deletes the JSON Web Token and deletes the refresh token. This might lead you naturally to wonder, well, can you revoke JSON Web Tokens? And the answer is sort of. Live by the attribute of statelessness, die by the attribute of statelessness is one way to think about this problem. If a user's JSON Web Token has been stolen, you have some options. You could rotate your keys. And if you rotate your keys and delete the key that was used to sign that JSON Web Token, that means that anybody consuming it won't be able to validate that JSON Web Token because the key that corresponds to it, what it was signed with, no longer exists. Obviously, that is a big deal because you're basically logging everybody out of your system. If that was an admin account, it may make sense. You could wait it out. This might be a solution if it is a low risk account, or if you have a really short time span for your JSON Web Tokens, 60 seconds, 30 seconds or whatnot, you could just wait it out. Or the last solution, which gives you more flexibility at the cost of more complexity, is to build a deny list. And so how that works is basically when someone logs out, or for any other reason, if a job gets stolen or whatnot, you build a list on each of the APIs that accept JSON Web Tokens and of invalid tokens. And so in this particular case, the user logs out. We go ahead and fire off a webhook, which goes to the to API. It maintains an in-memory or some other key value pair that says, hey, this JSON Web Token is because the user API knows which JSON Web Tokens it has issued, or a JSON Web Token for this user, right? Which means the user API can be simpler, is no longer valid. And so then if a JSON Web Token gets stolen and gets presented to the to API directly, it can consult that list and say, oh, this was for user Dan, but Dan logged out. Okay, I'm going to say no to this the same way I would is if the signature failed or if it didn't match the audience. All right. So, you know, and which of these approaches you pick actually depends on kind of what your risk profile is. How bad is it if this JSON Web Token gets stolen, and how quickly will you want to be able to revoke it? I'll also say that there is a standard out there that FusionAuth does not implement, but other well, actually, I don't know. I haven't done a survey. Other identity providers probably do, that lets you just revoke a JSON Web Token. And the reason why we haven't chosen to do that is really because it basically just puts you back into the opaque token kind of mindset where everything has to keep talking to the user API, because once you've tied that revocation to the user API, well, guess what? How does the user API know whether a JWT is revoked or not? It has to go back and talk to the user API somehow. Anyway, so as far as JWTs and Golang, you know, the question is, what are you trying to accomplish? If you're generating or parsing JSON Web Tokens, you want to use the JWT module. This is, I think it got moved in the last 4 or 5 months. It's really old code that the community has actually picked up, and I shouldn't say it's well written, well used, well tested code that I think the maintainer just wasn't using anymore, and so the community took it over, and now it's living, I think under. I'm not sure which organization it's under, but it's more of an open source thing. It was open source before; it was just somebody's module. You also want to make sure you check your claims if you are using it for authorization, right? If you're a consumer of a JSON Web Token, you can obviously do this you want to do this up at as close to the front of your request process as possible. So you might use a filter, or you might use like an API gateway, depending on what your deployment structure is, but that can check that. And your API gateway, I know there are some API gateways out there that aren't written in Go that have the ability, like I think Kong, I'm not sure what Kong is written in, but it has the ability to check a JWT and like do things like check the audience and check the expiration time and check the signature for you. So you might be able to get all that for close to free in terms of your development time. Here's the Jwt Tools. I already showed you the debugger. The code is here at this repo. It's Apache 2 license, so go wild with it if you want. And then I wrote about 3,000 words on how to use JWT securely from the perspective of the consumer, the client, the identity provider, and kind of what claims you should check and things like that. And I think with that, I'm going to end and say thank you very much. I appreciate you all sticking around, especially through kind of some of the snafus. If you want to talk about, you know, cat pictures or authentication or FusionAuth, feel free to reach out to me. And I think if people have other questions, happy to take questions right now. Great. If no questions, then I should probably give away the t-shirts. Oh, Gray, do you have something to say?
No, I don't. I'm just hanging around at the end for Ari.
Great, thanks. So I'm gonna pick Zhao. Are you in the US? Oh, okay. Well, Zhao, would you like either of the? Oh, I should have put this in the. Sorry about this. Would you like either of the ebooks? Zhao? Thanks, Pedro and Karen. Appreciate that. Okay, which one would you like, Zhao? Thank you, Jamal. Great. Then go ahead and you can send me a direct message with your email address, please, and I'll get that to you. Or share it in the public chat if you want. It's all good to me. I think I'm picking. Chris, are you in the US or Canada?
Yes, I am.
Great. Would you be interested in the t-shirt?
Sure.
Okay, great. So just drop your email address, either DM it to me or put it in the chat, and I'll be in touch with about that. And then last one is the Ultimate Guide to Outsourcing Auth. William, would you be interested in that? If not, it's not gonna hurt my feelings, but if you want, I can send it to you. Great. Please share your email address, William. And I will get that to you. And I think with that, I'm done. I would like to say again, thank you very much. Really appreciate your time today. And yeah, thanks very much. I really appreciate it. And the great questions too.
Yeah, thank you, Dan. That was a great talk. I really enjoyed it.